So we continue with the topic of the graph of sine and cosine functions. Remember that this is the graph of the basic sine function, y is equal to sine of x in one full cycle. And now we're going to continue with example number 2. They're asking me to graph the equation y is equal to 3 sine of 2x minus pi plus 2. Let's remember the first example that we saw. The difference between the equations. In the first example, my amplitude was 3. In the second example, my amplitude is also 3. It's a sine function because it doesn't say cosine, and we have not seen the cosine functions yet. Then, I still have a 2 as a coefficient of x, which is the value of b. The b that I'm going to be using in the period is 2. But the difference is that in the first example, I had plus pi, and the graph shifted to the left. In this example, I have minus pi, so that means that the graph is going to be moving to the right. And in the first example, I had nothing adding or subtracting to the function, to the whole function. In this second example, I have the plus 2 adding to the whole function that is given to me. So this means that my amplitude is going to have a value of 3. Remember that I get my amplitude from the coefficient of sine, that is going to be my amplitude, and it's always considered as positive. It's a positive number, so my amplitude is going to be 3. Then the b value comes from the coefficient of the x. That b value is 2. The b is 2. And remember that this b value that I obtained is the one that I use as a coefficient for the period. So my period is going to be, in this case, 2 pi over 2. I cancel the 2's, and my answer is pi. That means that the period of this graph is going to be pi. From there, I get the endpoints. My endpoints with the formula bx plus c is equal to 0 and bx plus c is equal to 2 pi. Remember that the part of bx plus c comes from this part of the equation, whatever is in the parentheses after sine. And I don't change the signs when I use it to solve for x. So is 2x minus pi, which is here, equals 0, and 2x minus pi is equal to 2 pi. From 0 to 2 pi, because remember that the original graph of the sine function goes from 0 to 2 pi in one cycle. So I solve for x, and I have one x value of pi over 2, and the other x value of 3 pi over 2. This means that my graph is going not as the original one from 0, but it is shifted pi over 2 units to the right from the original graph. I am shifting my graph from the origin pi over 2 units to the right. And it is going to be ending at 3 pi over 2. So from pi over 2 to 3 pi over 2, it's 1 pi, it's 1 unit of pi. So that's why my period is 1 pi. So what I'm going to do next, having the endpoints or the x values of the endpoints, what I'm going to do next is remember that I have to get my box. I have to enclose my graph in a box. So I am going to get those values in the coordinate plane. The first one exactly at pi over 2, and the other one at 3 pi over 2. And then the amplitude, in this case, remember that the graph is shifted 2 units up from the x-axis. In the other example, the graph stayed on the x-axis because I had nothing adding to the function. In this case, I have a plus 2. So that means that the average y value that in the original graph is at x is going to be shifted 2 units up. So this is the average y value, which is exactly at 2 on the y-axis. That would be my average y value. So the average y value is the equation y is equal to 2. Remember, it's not a point, it always has to be given as an equation. It's a line crossing the y-axis at 2. So the average y value is y is equal to 2. From the average y value is from where I get the other edges of the box. Remember that the average y value, which in this case is 3, is counted upward and downward from the average y value. So in this case, I go 3 units up from the shifted average y value, and I will end up 1, 2, 3, exactly at 5. That would be the highest point in the graph. And 1, 2, 3 units below the average y value is my other edge of the graph. So I already have my box beginning at pi over 2, ending at 3 pi over 2 in x. beginning at -1 in y and ending at 5 in y. From there, remember, I have to split my graph into 4 equal parts. So what I do is first I locate the middle. The middle of this period is exactly at pi. That would be my middle, the middle of the graph. Then, once that I have the middle, I get half of the first part, and this is exactly here, and the other one exactly there. So I have my first quarter, second quarter, third quarter, and fourth quarter of the graph. So what I do is, as with the original function that started at the origin, I start going up. Remember, I start at the origin in this one because the average y value was at the x-axis. In this case, I have to begin at the x-axis on the edge of the graph, on the horizontal edge of the graph, or x value. So my first point is there, and from there I go the first quarter, second quarter, third quarter, and I finish the graph in one full cycle. This would be the maximum point, this would be the minimum point. So let's get the domain and the range. The domain of the graph is going to be obtained for x is equal to pi over 2, and x goes all the way up to 3 pi over 2, which is the horizontal extension of the graph, pi over 2 to 3 pi over 2. So the domain for this one goes from pi over 2 to 3 pi over 2, and the range, which is the y extension of the graph, goes from -1 to +5, highest and lowest points, -1 to +5. There I have my domain and the range, and what I am missing is to get the endpoints, the actual coordinates of the endpoints. Remember that what I get here are only the x values of the endpoints. So the endpoints of this graph, which are the actual coordinates, will be pi over 2 in x, which is this value in the domain. Sorry, I forgot to enclose the domain. This value of the domain, pi over 2, or this x value in bx plus c formula, in the bx plus c formula. So one of the endpoints is pi over 2 at 2 in y, so it would be pi over 2, comma 2. And the other endpoint is going to be 3 pi over 2 at 2 also. And the endpoints are there. Remember, they are coordinates. This is half. What we get here is half the endpoints, is the x values of the endpoints. The endpoints are coordinates. That's a very common mistake. Be careful with that. So, having the complete example, that is what I am going to be getting. Alright guys, I realized reviewing this video that I made a mistake. While getting the amplitude, I mentioned that is what the average y value. Let's remember that the amplitude is 3 and it comes out from the coefficient of sine. And that is what I'm going to be counting above and below the average y value. The average y value is y is equal to 2, which is this line, and from there I go 3 units. I go 3 units above it, 1, 2, and 3, and 3 units below it. But those units correspond to the amplitude. I count them from the average y value. I hope I'm clear in this matter. Thanks.